All right, databases, MySQL and no MySQL. It's actually NoSql. Someone pointed that out to me a few minutes ago, hence the red line instead of actually fixing the graphic. So my initial desire for this talk was to basically be able to present to you the field of databases that are out there and give you recommendations about when to use what database. Maybe even compare the databases and give you actual stats on the database. And then I found this graph. And I decided that was a bad idea. I don't have that much time. I don't have that much patience. And what's even more embarrassing, that is 3 years old. So as you can see, there are a lot of databases out there. And don't worry, you don't have to remember any of this, because it's not really about any one of these actual databases, whether it is just 1DB or MemSQL, or I have no idea what this section of the database chart even means. There are actually, some sections that we can focus in on to get some value about deciding what we need to do with when deciding what database to use or what to do for our applications. So we all know what MySQL or SQL is, but the big question is, what's NoSQL? And a great article from Dataversity by Keith Foot, I don't know how to pronounce it actually. Basically, NoSQL has become an industry standard term, but the name is beginning to lose popularity since it doesn't fully cover the complexity and the range of the non-relational data stores that are available. So people say NoSQL like they used to say XML. I once went for a job interview where the person basically says, okay, this is great, but I need you to program it in XML. And I said, well, thank you. I just left because they did not know what they're talking about. Someone who just says, oh, I need NoSQL has no idea probably what they're talking about. Because NoSQL simply means I need a database that doesn't have an SQL query language, which actually some of the NoSQL languages actually do have. But that's neither here nor there. So what are we talking about when we talk about databases? So we have the RDBMS, or RDMS. I missed a B there. Anyway, we have relational database management systems. These are the ones you're really familiar with. The MySQL, Microsoft SQL Server, Oracle, PostgreSQL, SQLite for being fairly file-based, and there are tons and tons more. But then there are these other components, and they're changing over time. Basically, it's kind of more of a progression this way. They kind of started with the key-value pairing, which is basically the most popular is Memcache. It's you have a key, you have a value, you have a database. This is how you can look things up. There's Hazelcast, Redis, again, just a small portion of what's available. And these all come out of the idea of this is a key-value store. It's a database type. It's NoSQL in the sense of you don't need a querying language to look this up, because in key-value pairing, you look up the key, you get the value, and hey, you're done. There are no joins, there are no anything of this. You basically, you have one thing, but you need the other. The latest application where I used this on was we have a key for our internal data information, and we're working with a third party, and they have their own key, and we need to be able to look that up quickly. So we used a key value store to basically say the key is our key, our index, and the value is theirs. So we hit this thing, we give it ours, we get theirs, and we send it off to the third party. That's basically the key value store. The next thing of the basically, if you haven't figured this out, this whole group right here is considered NoSQL. And that's why anyone who says, oh, it needs to be NoSQL has no idea what he's talking about, because they're vastly different. So from a key value pair to more complex, and probably the most versatile and more popular nowadays, is the document store. So with the document store, you have DynamoDB, Couchbase, MongoDB. So again, this is basically a key value store. You have a key, and from it you get a value. The value, though, is normally JSON. It's fairly complex. It itself has key value pairs. But what the document database gives you is an ability to query, to actually draw information, to pull things from like, oh, give me all of the documents that have the attribute of they're in the city Phoenix. And it will do that for you. Some of them actually do have an SQL-like language for querying, but they're the next upper step from that. They also can give you quite actually a bit more capacity than a traditional RDBS gives you. But we're going to get really a lot more into that. Going into more of the complexity scale is something called a column-wide database. And this is basically, which melts my brain, it's a database that stores the information in rows. One row is an entire entity, but the columns are sorted by a name and a timestamp. And then there's something about relevance, which I haven't figured out yet. One thing you're going to learn from this talk is that I'm really not going to get too specific about how each of these work. It's just kind of giving you a flavor, giving you an idea, trying to help you understand when would I actually need one of these. But basically, these are the big daddies. This is about if you need huge data sets. A great quote that I read, if your database fits on one server, you do not need this column. It's too small. And when they're talking big, they're talking huge. I've had like PostgreSQL databases which have had millions and millions of records, and these guys would have looked at that and said, "Oh, that's so cute. You're just in the in the shallow end of the pool." So basically, this is Google's big table, Cassandra and HBase. These are the column-wide tables. They are for high write, huge data sets and analytics. The fourth is graph databases. These are a totally different type, whereas these are all kind of, actually even this one, they're all kind of a key to value or row of values type thing. Graph databases are all about networks. They're more about you have an identity, you have an object, you have a node, and how does that node relate to other things? And that is how it gets queried. So again, this is totally alien compared to these guys, which are totally different than this guy. But when someone says NoSql, they are unwittingly talking about all of this. So that's kind of our problem. That someone says, I want you to build this using NoSql. And it's like, you probably don't know what you're talking about. Because to evaluate which one you need, you actually really kind of need to take a look at what's going on. So the first idea is there's so many, from what the first slide that I showed, there's so many options available. The best thing to say is, what is actually popular? Well, dbengineers.com actually tried a ranking system, and they have, it's basically ranked upon number of posts that they see about it, number of mentions, number of technical articles, general interest, and this is their ranking. And as you can see, they do give from last year to this year, from last month to this month. And Oracle is at the top. In fact, out of the top 10, most of them are relational databases. You have MongoDB, which is a document store. You have Cassandra, that's a big wide column. And Redis, a key value store. So those are your top 10. I included the top 21 because I wanted to show Splunk, which is something that we use here at Ticketmaster, which is labeled as a search engine. We won't be covering that because I don't know what that is. And I went all the way down to 21 because there is Neo4j, which is the first and most popular of the graphing databases. So this is something that gets updated pretty much. Well, I mean, it seems on a daily basis, at least monthly basis. So if you're using this information that I'm going to present here, and you're looking for, hey, what should I be using on my current project, you can go here and see what's currently available. So the first thing that we really need to cover before we talk about MySql versus NoSql is ACID versus base. So if you've worked with relational databases, you're very familiar with ACID. It's atomicity, consistency, isolation, durability. Atomicity. If I tell you to do something, you're going to do the entire thing. If I'm basically telling you, I need every column in this, every value in this column set to 1, you're not going to stop until every column is. If you die halfway through, then you're going to revert to a state where it was as it was before I even started. Consistency basically means that I will meet the rules that are implied in the database. If the value that I'm trying to update to is a Boolean and I'm trying to set it to A, it's not going to work. if I'm trying to set the value to 56, but I have a business rule in there saying, no, this can't be more than 42, it won't work. Isolation. That means what I'm doing, my transaction to the database, is isolated from everyone else's interaction with that database. So when I decide to do something and update row number 6, and you're trying to update row number 6, my transaction is independent of yours. And that gets resolved later somehow. I don't know how, but it does. Durability. That means that once my transaction is done, it is done. It is there. If I lose power, but my transaction was finished, when it comes back up, I'm done. That is ACID. It basically says, once I'm done, I have consistency, I have, well, isolation, I have durability, and atomicity. The other side of this, if you're into chemistry, you'll know that a solution that's not an acid, well, it's a base. So they got an acronym for that. Basically available. It means that the service is available. However, you might get a fail from it. It says, yes, I'm here, I can talk to you. I have no idea what this row is that I know you just inserted, or that you know that you just inserted. I just don't know about it yet. The database is up and running, but it hasn't gotten your information yet. Soft state. This goes back to, well, everything's up, but we may not have all the information. If I have 30 nodes in my cluster, and I stop receiving any type of requests, the state is still soft. It still may be changing, even though nothing's actually happening. Node 1 might have the most updated information, and it may take so long for node 30 to get all that information. Eventual consistency. This goes back to the soft state. Base says that I might not be consistent right now, but if you give me enough time, I will get there. I will improve. I will get better. It's that way. But so this is one big major thing is, are you living in a world where you need ACID? Or can you live in a world where, hey, base is okay because this can get you a lot of power? It's needing everything to be right that constrains us. And this is where NoSql comes in. It lives primarily under the base model. So why then do we have so many NoSql variants? I mean, I showed you the first slide. There was a phone call coming in, and I did not mute my computer. There we go. Sorry. Why are there so many NoSql options? It's because of the cap theory. The cap theory, or Brewer's theorem, basically says you get consistency, you have availability, and you have partition tolerance. So capacity, or consistency is the system reliable? Is it there? Does it have the information that it needs? Is it correct? Availability means, is it up and responding? Partition tolerance means that if something goes down, if I lose a node, do I lose my data? Or am I tolerant? Can I retain all my data? Cap theory says you get two of those in a distributed system. If you're on one computer, it doesn't matter, you're great, because you don't have any race conditions, you don't have any network latencies. But if you're working in something that has to be available to take a lot of read and writes, you need a distributed system, and that's where this comes in. And this is where all the different systems come. So if you're choosing one and you decide to go with a NoSql option because you're ready to sacrifice one of these, you need to figure out which one it is. And that's how you move forward. So I stole this from Andrew C. Oliver. It's an old graphic, it's from 2012, but it's a really very simple way of looking at it. It's basically, as your data complexity, as you get more complex data and you get bigger data, these are kind of where you should be looking. Of course, we don't have column family anymore, really. And graph will be more over here, and then somewhere up here, we'd have the column width family. But it kind of gives you an idea. Now, relational databases, they can handle a lot of load. This is not trying to say, oh, if you have 1 million records, it's too big for a relational database. If you have 10 million, maybe it's time to start looking somewhere else. But it's kind of just a really simple way, probably oversimplified, but it's just a way of kind of keeping your mind wrapped around it. If you have modest gains or modest things that you need, a relational database will be fine for you, unless there are other circumstances like complex data. There are better things for you. So I just thought I'd throw that in there. So let's look at some pros and cons. RDBMSs, the old style, PostgreSQL, SQL Server, all those. What makes them so great? Well, they work with structured data. They support ACID, so you know you have consistency. You have a built-in data integrity. This basically means that, again, as I said before, if you're inserting a 1, it's into a field that can't support it, it will throw an error on its own. Some databases, in fact most nowadays, basically are able to enforce business logic. If you have a business that wants to bring its logic all the way down to the database so that even if someone is entering it with a command, with a CLI, is forced to adhere to business logic, you can do that here. It allows you to that. It has that integrity. It has triggers. It has all of that. Relationships have constraints. So basically, you can't delete something from one table if it exists in another table. Indexing. So if you need a query to go faster, you can find the right index, and therefore you can make your query faster. And of course, SQL. You have a very rich language that a lot of people understand, and you can get someone with relatively no experience to walk up to your database and start understanding how to interact with it. And one of my favorites is you don't need to understand exactly how is your user going to consume data. If your user wants to create a very convoluted query with 30 joins, they can. It may take a while, but they can do that. Oops. So on the con side, RDBMSs, they scale more vertically. In other words, if you need to serve more people, you need to get a beefier box. You need to add more RAM. You need to do many things to make that one single box bigger. You can create more boxes, but then you say, well, is it a master-slave situation? Are they both writable? If they are both writable, what happens with rates conditions? It gets very messy here. And it's all left up to you. And it's expensive. Data is normalized, which in itself can be a con. Some people say it's good, but it really makes things slow. A flat text file is hugely faster than any type of database, even if it only has 2 columns, simply because of the normalization and all the lookups it has to do. So there is a cost to normalization, a speed cost. And of course, you need to know kind of what you're storing before you store it. If you're going to store something about a person, do you need to also store their address? Do you need to store their social security number? Because if you get it wrong and you're 100,000 rows in, you have to add a column, that gets expensive. Whereas NoSql, hey, I got it right here. The pros are it scales out horizontally. You need more capacity. Well, you throw in another cheap hard metal or virtual machine that basically over time gets all the right data, but hey, it can serve traffic right away. It may be wrong, but it'll eventually get there to consistency. Works with unstructured or semi-structured data, and we'll get a little bit more into what that means later, but you don't have to know what you're storing before you get going with it. High availability, again, most of these will be available. They may not have the information you're looking for. Again, you may have just sent in the insert statement and you say, okay, give me that back. And it says, I have no idea what you're talking about. But it will be there to say, hey, I have no idea what you're talking about. So the cons to NoSql, again, it's base instead of ACID. This is changing because some NoSql databases are trying to strive for an ACID type compliance, which is really cool, but again, things are changing rapidly, so that's up to you to keep up to it. There are limited supports for joins, so if you have 2 pieces of information in 2 different areas, trying to join that together is not as easy. It's a little bit more complicated. And because of the joining thing, it's denormalized. So if you have a database with 100,000 entries into it, and they all live in Arizona, and now all of a sudden you have some customers that are from Mexico and you say, oh, I have to add a country to it. You got a lot of inserting to do, unless you want to make an assumption. But again, no built-in data integrity because it is basically unstructured data that you're putting into it. So those are the pros and cons. So let's kind of look real quick at some of the individual types. I know I'm kind of speeding through a lot of this. It's just a lot of ground to cover, and I don't want to spend too much time because the ultimate goal is to try to help you understand which one of these you actually need. So all this was to kind of look at the individual ones. So this is the KeyValue Pair. This is basically like your memcached. Great for frequent small read and writes, simple data models. A A key value pair is simply that. You don't want to store much more in it than this is my key, this is my value. Now, your value can actually be fairly complex, like user data during a session on like a mobile app. I'm logged into my app, Clash of Clans, and it needs to know that I'm Eric, I'm this Google account ID number. I have all this information. They really don't care to put that anywhere permanent. They need it for 5 minutes while I'm on the app. This is great. This is Eric, this is his information. We need to refresh this like once a day, maybe even less. So, as I said, user data during a session, caching is a great way of using this. It's basically you've calculated a large thing. It doesn't change that often. So you say, hey, keep this in your data store for like 10, 20 minutes, and we'll look at it again after 20 minutes because it probably doesn't change in that time. Transient data. Shopping carts are a great example of this. If you have a user who's in your store, they're putting things in, they're throwing things out, you don't want to create an actual table for that. You just want to say, here's the user ID, here is their current state of a cart, and let's keep a hold of that. So this is a great idea for that. Again, frequent, small read and writes. We're not talking large data. One kind of exemption is a large static store. So if you have images that, of course, images are not going to change. You're not going to need to know anything more about this image or audio files. You just need to reference it real quickly and get it fast. Most of the time, key value stores are in memory. They can be, backed up to file disk, but this is their specialty. If you have simple data or data that changes very infrequently, this is definitely the way to go. Oh, yes, go ahead.
Take an audio file or maybe a video file. So I have indexed it using multiple parameters, maybe the genre, the artist, or whatever. But I don't want to have multiple of those files because those are heavy files, those are huge files.
Mm-hmm.
So essentially, I have multiple keys to a single value. Is that a possibility in this situation? What kind of?
So the question basically being if, especially on the images and audio files, if I have multiple ways of referencing it, but I don't want to store it, there, if it's a 1 gig audio file, I don't want to store it 10 times because I have 10 ways of pointing to it. I'm sure there is a database, there is a solution already pre-built out there. The way that I would approach that is definitely stay with the key value store. Is I would have like one main entry, probably one that isn't actually referenced from the outside, and then those 10 entries, or however many different entries you have to that, you can then point to a value which then will eventually pull that up. And maybe you have some way of referencing. You would have to figure out a mechanism for that. The easiest instant way of doing that, if you know that you have 10 unique ways of, I'm going to reference this by name, location, date, timestamp, is you take all 10 of those, you put them together, and you hash them. And then you get one unique hash that you would then use in all locations. Because it would...
looking up based on one of them, though there are 10 ways to look that up, I can use only one key to basically look that up.
Yes, you're right.
Them together will not...
Correct, yes. There is definitely no way in the key value store to be able to have multiple ways of pointing one value. You could do a memory location. Sorry, go ahead.
Couldn't you have two tables, and the first one is just the value is a reference to the other table?
Yes.
Basically, key value to a key value.
Yeah.
Yes, so you can definitely, the question is, one of the solutions is you could have a key value store which has the original data.
That might be an option.
Yeah, which has the original data. Then you have a secondary key value store which then points to the original information. So yeah, there's nothing saying that all of these key values, and there's a way, are the same thing. You can have multiple databases. In fact, you can have multiple ways of running this. So there are ways of attacking that, but generically the way key values work, no, you cannot have one database that's going to say, oh, all of these point to the same object. It is a unique key to value correlation. Does that answer your question?
Yes, I think this is probably the way we should look at it.
Yeah.
Yes.
So you give up a little speed because you're hitting two tables, but you only have to store the data once.
But still it is fast because it is still a key value.
And it'll probably be all in memory, yeah. And I might be mixing things up. I believe some of the key value databases do offer like a namespacing. So you could say, okay, in my lookup area, I get this value, which then becomes the key for my storage area. So again, I might have confused two things here. So something you can look in for. All right, document data. Oh, sorry, go ahead.
I didn't know we were doing questions.
Oh, no, questions are great, please. I'm sorry, I should have mentioned it ahead of time.
Oh, no,
Go ahead.
that's okay. I had a question for a slide
Sure.
for something a few slides back. You mentioned that some NoSql databases are moving towards supporting ACID. What technologies are doing that? Because I've never heard of that before, but it sounds like something that would be really useful.
That's a great question. He's asking about this slide here. I just know that they are.
Okay.
I applaud them and I say go for it. And when you're done and they have it available, I'm going to take a look and figure out how they do it. Again, yeah, these unfortunately are not deep dives. It is just something that is happening. Yes?
But isn't the ACID properties sometimes against what you have in base properties? So
Yes.
typically, for example, consistency and eventual consistency.
Correct. Yeah. You are right that ACID does go against what a NoSql is. And so again, I'm looking forward. I mean, people are working on this and trying to make it better and better. And I don't know if it's just going to be like a really hard base or a very acidic base that they're going to come out with, or whether they're going to actually fix this somehow, or whether they're just going to come with a very basic ACID going. I don't know. It's again, these are things that are changing fairly quickly. And it kind of makes a talk like this hard, and it's kind of why I'm trying to keep it a little bit general. But I just wanted to put out that to say that, the con to NoSql is its base only is not totally correct. And again, these are things that you will have to evaluate as you go on. But yeah, definitely questions. Please keep them coming. Definitely, as we go along. That's great. Document databases. These are kind of what's most popular right now. This is kind of where you get your coming together of a relational database and NoSql. These are designed for flexibilities, and they store varying amounts of attributes for large data sets, and that's where you get the power here. Just because if you're trying to log products, a DVD player is not going to have an ISBN number like a book. So you don't have to have an ISBN number column like you would have a relational database. So it does offer some indexing and filtering available. You can search as what is in the document as well with filtering and other technologies. Basically, general uses you would use this for is kind of the same thing you would use for a regular relational database. Any type of web page where you have high read and writes. Again, this will be where you have higher read and writes, but you're okay with a little bit of all the data is not quite consistent yet. And basically anything with variable attributes, like I said, products. Is it an apple? Is it a chair? Very different attributes, but they're both products that you would like to sell, or Amazon's trying to sell to us right now. So,
Question on
yes.
DB. Is anybody aware of any document DB that supports XML?
I believe so. The question is whether there are document databases that support XML. I want to say yes. I don't have that on the top of my, remind me of that afterwards and we can look it up. I'm fairly certain that it's actually any actual structured language, whether it's JSON, XML, or even...
JSON is supported.
Right, yes.
DB at least supports JSON, but XML they break because I don't know whether they are storing it that way or whatever happens, they're not supporting XML as
Okay.
of now.
The
The reason I'm using XML is if you look at how enterprises are communicating today, much of it is still XML. And you are in this state wherein you are trying to modernize pieces of it, but then there are other pieces which you cannot touch, cannot hand over. So that's when you need XML.
That's being sarcastic.
So yeah. So basically, the point being made is that a lot of businesses still use XML, even though JSON seems to be the current favorite. And that may be the rub. I'm sure that it has to exist because a document database, it doesn't really care what's in the document. Now, Okay, the theory says it doesn't care. The individual designers do care because they are making things faster by programming for a certain type. So it may be, yeah, that XML is being left behind, and unfortunately, maybe they don't. Maybe they have an older version. But the theory of a document database should be what's in the document doesn't matter. Of course, we all know that. You know, that's great for a manager to say. For us, it really sucks. But yeah, but yeah, we'll look that up afterwards because I cannot believe that everyone's abandoned XML, not with what we have available nowadays. Okay, so we got the general uses out of that. RDBMSs, I'm just throwing these in there. I feel like these are old friends, and we should all know this. But since I gave shrift to the other ones, we're doing this one. Again, as I said before, enforces data is integrity. We'll come back to number 2. I should put that at the bottom. SQL. Everyone knows SQL. It's great. ACID, we know what we get in the database, and we're guaranteed of it. User level security. RDBMSs, I'm sure that the NoSQLs are coming up on this. This is pretty much the only thing that has a mature level of security where you can tie things down on a table, even row or table or column basis. Let's put it that way. NoSQL databases are still struggling with exactly what they're trying to do with it, other than the grand, security measure of once you can have access to me. If you need security saying that this user can only see this table, let alone touch this table, that you need to stay here for right now. It'll probably be changing really quick. By the time this code gets up online, they may have already figured it out. But things are changing that quickly. But for right now, if you need actual security, you are stuck with the relational databases because they are older and much more secure.
I do not really agree to that.
Okay.
Yes, if you at the database level, RDBMS is just being there so long in the market, it is much more mature in terms of what it has. But NoSqls are being used, and yes, it has to be wrapped with security externally, but that's how it's being used right now.
True. So the point being made is that you can enforce the security externally, and that is where a lot of it comes from. And you're right, but it is external. It's not hardened into the thing. And I'm sure it will be coming. But yeah, for right now, if you need to guarantee that, if I connect to your database from some type of a command line tool that I fashioned out of, a coconut and some wire, you want to make sure that I still can't connect to it. You don't want your security living in an outside layer. Again, this level of security really it has its places. Most places don't need that intense. But if you need security at the level where you're saying this person can only touch this row or this column or this table, it really does need to be baked into the security system. I agree that there are answers for the NoSQL, but again, there are also wrappers, and there are ways to get around wrappers, and that can be dangerous, especially if you go to financial systems. And that's very specific topic, and that's actually where RDBMSs will kind of, I feel, always live. They will always live in a financial tech center. They have basically structured business transactions. You want a relational databases if you need to do computations across all of your data. If you need to do sums or averages, this still has the edge. Again, I can't talk about what's coming in the future, but if you need to basically look at every record and add one column of it together, this will be faster because you can index on it. There are indexes that are coming for some document stores, but this is still the recommended path for right now. That's where the calculations comes in. And again, these are general guidelines for when you're selecting something. If you are looking at like an enterprise level solution, you need to really look at everything, very close because every little thing matters. This is more of a general idea. This is to get you in the right direction. So column-wide, these are the newer ones. These are the bigger ones. It's large data volumes. And again, when I say large data volumes, if your database is anywhere close to still fitting on one box, this is not for you. I've not actually even played with any of these. They look exciting, but they look for the amounts of data that I can't even fathom. They need to be always writable. So basically, if you send something to it, you need to guarantee that somehow one of the node picks it up and will eventually propagate it to everything else. And because of that, your application, the user, the client, needs to be able to handle some short-term inconsistency. You know, if your aunt likes your photo, if, you know, a node that your brother is connecting to doesn't pick that up for, you know, 10, 15 seconds, that's okay. No one cares. Your aunt might, but that's about it. You know, you need to be okay with those inconsistencies. So the general uses, again, like I said, well, I didn't say here. Sorry, that's the next one. Any type of security analytics, bioinformatics, so trading analysis, anything where there are large amounts of data, this is going to be a great way of going. And I wish I could describe it in better detail. The same one with the graph DBs. These sound really exciting. This is where you get your social networking, and this is where the example of the aunt liking my post and my brother not knowing about it should have actually gone. So I apologize about that. The only thing I know about these is it's basically data or nodes. A node is an entire entity, so I would be a node. The data on each of the nodes is represented through relationships. I am a node, my credit card's a node, I've made transactions, those are the relationships. The graph databases are very good at connecting those, basically of being able to find patterns of how things go together. So basically identity and access management is a great one. Social networking, again, it's basically where you can say, hey, I want to fly from Phoenix to Hong Kong. What's the cheapest way of doing it? And this will be the way. Basically, they call them edges where the relationships meet, and they can figure out very quickly through mining of those relationships how to get that best trip available at the cheapest price. So again, large data sets, very alien from what we normally know. So, but also more cutting edge of, it's something if you're doing social engineering, this is what you'll be using. If you're trying to do something with geographical points, this is what you would use. And of course, the last two I'm most unfamiliar yet. So with all of this, what I've said, how do you decide what to actually use? It's a lot of information. And as you can tell, most of it, I really don't even know the answers to myself. There are a lot of things coming down the pipe. But the number one answer that I finally find, that I think is, does your language support it? If you're writing in Perl, does Perl have a driver for, what is it, NEO4J, for graphing? If it doesn't, then you're SOL, unless you want to write that driver. And if you work for a company that's willing to give you that money, go for it. But really, who wants to write a driver? I'm sure there are people out there, but not me. So that's the number one thing, is can you actually technologically do it? Then it gets into actually really more specific things. What's your volume of read and writes? If it's being written to once a day and being read 1,000 times a minute, that's totally different of, oh, I got to write to it all the time. The nature of the relationship between entities, and it's more of how is the data going to be pulled back out? Is it more static information that doesn't change a lot, or is it very convoluted information, very almost arbitrary information that has connections? Again, are you using graph, or are you just going to use a relational database, or will the document database work for you? Availability and disaster recovery. Most relational databases, they sit on one box. They may have a slave, and if you have a failover, if you're really good, then you have a really fast failover so you don't actually see anything, but you're still working from one computer to another computer. Where most NoSQLs, you can throw in more things that will automatically replicate. The replication's built into these. Whereas with the relational databases, you kind of have to figure out a strategy for it. The need of flexibility of the data. Is this like one person and you have 1,000 of these people and they all look and act the same? Or is it a product thing where you have a computer which has a CPU and you have a chair which has a height and a depth, and you need to store product information, but they're very unrelated to each other? Do you need that kind of flexibility? And of course, tolerance for inconsistent data. If you're going to be working with a programming language or with a client who basically says, I need everything to come in exactly this way, maybe NoSQL is not the way to go, because it's all about flexibility. And your client needs everything in this meticulous manner. Or maybe you do use that and you just have a big ass filter in the front of it to make sure it's right. But the bigger thing is, do you need to settle for just one of these? I mean, if you think about it, how many people have actually just worked in a place where you've only used one database solution, where you've had a relational database and you've not used a cache? Oh, really? Okay, cool. I thought I was the only idiot. My first job, and my only defense is that this was before memcache was really a thing, and I understood even what computer programming was. In a database, I had a table called data, and it was literally a key value store. And it was my way of figuring out how to cache data inside a relational database. It was very inefficient, but it worked for me. So, but you know, in most modern applications, you're going to have your main database, and then you'll have a key value store, a caching system. You may have a document store for oddities. Feel free to use, use the best tool available. If you have one section of your code that basically screams for something that's inconsistent, you go ahead and use a different database. Don't try to take your financial part of your information and form it into documents when it really works well in a relational database. While then trying to take all this crazy data that you have about your products and then stuff them into these relational tables. Feel free to have more than one.
Another question, please.
Yes, question.
So, understood that from volumes and like throughput and availability perspective, NoSqls or these kind of databases are far ahead of RDBMS. What about performance?
When you say performance, though?
If I have to read and write at like milliseconds, 5 milliseconds, I have to write back, read or write to the database.
So if you have really and this is where the hard part puts in, is how big is what you're reading and writing? How flexible are you on so the writing ability, if you're tied to one node, the read and writes are going to be fast. But if you are interacting with a cluster, you're not guaranteed that if you sent in a write, that the read is going to go to the same cluster, unless you have some type of a session stickiness that you have programmed in. So again, this is why with NoSql, you can write to them much faster and you can read from them much faster, but you also have to be ready for data inconsistency. And if you want, I can definitely prepare a presentation that will dive deeper into like one of these things that try to, that there are strategies for dealing with data inconsistency, but something you have to give up. If your need is very fast read and very fast writes, but you also need very fast consistency, then you're probably looking at a very expensive box that can handle that all by itself. Or, yeah.
Consistency will probably come in later, but if the requirement is reading fast, say we are talking about just reads right now.
Mm-hmm.
Okay? I need to get my account balance. I'm at a point of sale, I need to get my account balance for whatever reason. Now that has to be really fast.
Yes.
Now, would I be going in for, you said that NoSqls are very fast in it.
Yeah, well, yes, but not for computationals. So the way that you could get around that with a relational database is, let's say you have an account with a transactional table. Well, you can create an index and a trigger on that every time I do something to my account, I make a deposit, I make a withdrawal, there is a secondary table, and this could be a virtual table, which gets updated with the total. And then that information could be distributed in geographical manners so that when you're, let's say you're at home here in Phoenix, but all of a sudden you find yourself in, in France and you want to see your balance, it can be sent to you right away because there's no computation needed at that second. So there's strategies for that, but each one of those strategies and this is where this gets really important. You need to decide, what do you need? Do you need calculations first off? Then that's going to push you more towards a relational database. It doesn't say that you have to use that. And there could be strategies that other ones will be faster. But you're probably, if you are looking at having a large number of records and you're trying to sum them, then it probably would be better to look at, okay, when does that column change? And I'm going to put in triggers onto that.
So if
Yep.
it is just retrieving a value, not doing any computation.
Mm-hmm.
So given where RDBMSs are today, would RDBMS be be able to retrieve it faster given that it is running on a single node? It might be very expensive for me to get.
Well, the question is if you're just trying to retrieve one piece of information, that kind of leads itself is what is that information, and could you get that from a key value store? See, and this is where you have to think about it. So the RDBMSs, they give you I would think their strength is that calculational power, is things are indexed so you can bring them together real fast. On organized, homogeneous data, if it's all over the place, then yeah, you're looking at a document store, but then you need to look at different strategies. But even if you have that well-indexed, well-homogenized data, and you're just trying to sum things up, you're probably still going to want to add on to it a key value store of some type that basically says, I'm going to hold the total of this field or the average of this field, because it's a piece of information that's kind of expensive, but it doesn't change that often. Or when it changes, I can be triggered to update myself rather than trying to do that. You know, it basically, you're looking at a caching strategy on top of your database strategy.
Okay.
I don't know if I'm answering your questions on that or
I think at least the discussion is helping me.
Okay, good. Good.
See, as a developer,
So-
though, I would rather have one database solution than multiples, unless I really had a lot of reasons for multiple. So in that case, I would just use another table, hash value table, in a relational database. It'd be fast. And
Yeah.
you could still access it from a variety of locations. So
Yeah, so the comment was,
having another database to deal with.
so let me just wrap this up and then we can continue the discussion just for anyone viewing at home. Basically, the point was that there is merit to having one database because it, like, you know, programming in one language, then you really only need that one approach. So again, do you need to settle for just one type? A very important question as far as all of these is you need to kind of value look at the pros and cons for everything to figure out whether do you need just one approach? Is this going to be such a complex thing you're going to need to throw so many people at it? You need the simplicity of this is the uniform way of going at it. And by doing that, we're taking this hit, and we are okay with it. This is the whole thing about anyone who comes up to you says, we need PostgreSQL because it is the only thing that will do it, or we need NoSql because it's the only thing that will do this. It's just like, no, it's not that simple. We need to step back because there are different types and there are different approaches for it. And once you're in it, there are ways of working around all sorts of problems. So real quick, as far as resources goes, and these slides will be available up online, this talk originally came from the idea of 7 databases in 7 weeks. Really great if you're looking to get your hands dirty and just have easy examples. You can burn through this book again in 7 weeks faster if you feel motivated. That book and internet searches led me to NoSql for Mere Mortals. That was actually a tremendous resource. I would highly recommend that book. Also, a review of different database types, relationships versus non-relational databases by Keith. I would recommend those. And of course, again, the dbengines.com. That's where you can see what's hot, what's not in the database world. So thank you very much for coming out tonight. You guys have a good night. We're going to keep...
Question?
Yes.
Since this is a Perl Mongers meeting, can you tell me on that slide at the beginning, which databases does Perl support?
No, I can't. So Perl, fortunately, through the DBI, how about we'll go with this guy. Perl through the DBI module actually has definitely support for, I don't know about Elasticsearch, but definitely these 10. HBase, I don't think it has any support for Splunk. MariaDB, I believe it does. I don't know about and Neo4j. But check out cpan.com and you should be able to find it there. Yeah?
Okay, and I guess and related to that, Perl 5 and Perl 6 later is available.
Oh yeah, and whether it's even available in Perl 6. Honestly, I don't know where the Perl 6, honestly, yeah, I should have installed an actual slide on this. I will figure this out and I will add it to the presentation so we have it on the Meetup site and then we're on the YouTube site as well. Thank you very much for reminding me about that. Yes, but for most of these you will find Perl modules that will help you connect to these. So, hence Perlmongers. So, thank you very much. You guys have a good night.